We're going to take the next 10 minutes to really go through just how all of this is coming together. The intent is not to make you experts on how AI works in the back end, but just have some familiarity on the building blocks of it. Okay, let's understand the constructs of AI. So AI is equivalent to large language models, right? These large language models could be text models like we saw, it could be image models, it could be voice models, it could be speech model like speech to text or text to speech models, video models, etc. So when we talk about constructs of large language models, we're talking about all modalities of models here. How does it all come together? First of all of you are talking to these models through some kind of a user interface. User interfaces, you go to ChatGPT, you go to Gemini, you go to Claude, etc. Right? We're all very familiar with it. This is your interactive layer. How do you talk to AI? And that's why it's very important that you use this layer really effectively, because that is your medium to talk to AI. That's why writing effective prompts is so important. The second thing is the prompt itself. These are the instructions in the context you're going to provide, and the more context you can provide, not too much context, but the right amount of context, just like when you're working with humans. If you just do a complete brain dump on first meeting, the person is going to forget and it's going to miss a lot of that context in the output it's going to produce. So think about how would you incrementally provide that context so you can continue to ground the person's understanding in your business or your specific task at hand. So those two things are fundamental. We've talked about it. In the back end, how all of this works is that everything that you are writing through this interface, which is your prompt, is ultimately getting converted into a token. So token is the smallest unit of text that AI or the machine can understand. So when you give it a word sunrise, it's not reading it as sunrise, it's reading it as a token. And the word sunrise might actually get split into two tokens, one for sun, one for rise. Okay, so first, anytime you give it a prompt, the machine is chunking it down into smaller tokens. And then those tokens are being converted into numerical representations. And we'll see what that looks like. So the machine is not really reading any of your words. The machine is actually working with embeddings, which are numerical representations, like 1, 2, 3, 5, 6, 7. So what's happening is in the entire, if you think about a graph, a million vector space graph, the embedding is telling it based on all the embeddings that I have for this particular task, this is where I have to go look for more information. So if the embedding matches the embedding of cat, it knows that, okay, cat can be talked about in terms of color, in terms of size, in terms of sounds, and things like that. That's how AI knows that's the context, right? This is how I'm going to go find the relevant information for a cat in my vector space. We'll look at what that looks like. The fourth thing is the context window. So context window is a thread. So when I go to ChatGPT or Gemini or Claude, anywhere, I start a conversation. That creates a thread. We all see our threads here in the left-hand sidebar. So now what I'm doing is I'm starting a new thread, and I can go back and forth on this thread. Everything that I am having a conversation with AI now is specific to this context window. So this context window is the input that I provided, which is my prompt, and also the output that AI provided. So when I'm sending this follow-up prompt, every time I'm sending a follow-up prompt, everything that is there before in this particular thread is going back in AI all over again. So this is your context window. This is how the machine is understanding the entire context of your conversation. Why this matters is that there are limits to the amount of context that a model, which varies by each model, the size of the model, the context window might vary by each model. So if you never refresh a thread, if you never start a new chat when your context changes, the conversation, the nature of the conversation changes, what's going to happen is beyond a point, the model is going to stop forgetting the first or the second prompt and response that it had. It's going to start dropping the previous context in this thread because it has a recency bias. Which means that if your very first prompt had some ground rules about you or what to do, what not to do, it's going to drop. Suddenly it's going to start to hallucinate. So it's very important to understand that when you are starting a conversation, you are working within that context window. That's what context means. So it's all of the prompt, all of the instructions that all of the prompt that you're giving, all of the response that it's giving, the follow-up prompt you're giving, the follow-up response it's giving, everything is going back into the machine and getting converted into tokens and embeddings each time. Beyond a point, it will reach its threshold and it's going to start to drift and it's going to start to hallucinate. So as a good practice, it's a good practice to separate your threads by different tasks and start a new thread when you've battled something enough. Or if you feel that, hey, this thread is completely going down the wrong path, it's already started to hallucinate, abandon it, start a new one. It's more about good practices. It's about, hey, I have battled this enough. It's time to start a new thread because I'm changing my perspective. I'm starting a new context or something like that. So it's not how many days. I go back to my old threads. I work within project. So if I go to like my LinkedIn content, this is my LinkedIn content project. And then within this project, I have a lot of my past threads. I'll go back and pick up a thread because I was writing a post that I never finished.
Yeah.
So it's not about the duration, it's about how much content is there in that context window. But you can always, if you find that you've had enough, you can always say, summarize all the information for me from this thread to launch another, something like that. So then you take that information, copy it, and then you start with the next one with your prompt. The other thing I want to call out is that at a high level inference, just like humans, you give it a task, you give it some context, it has to make logical sense and it infers. Once it infers that, then it goes and performs that task. That's why clarity of your prompt and context window mindful use is important because that's what steers the inference for the model to say, okay, this is where I have to go. You're talking about emotions, you're talking about colors, you're talking about size, things like that. So it's taking a lot of clues from your prompts to infer what the user's intent is. So make sure your prompts are clear so that you can steer it to understand your intent accurately. The last thing I want to bring up is temperature. This is important if you're so generally to understand maybe the concept of temperature is that when AI is generating a response, it's nothing but a probability machine. Literally, if you ever read about what's happening in the back end, it's statistics, mathematics, probability. That's what it is. So anytime AI generates a response, it actually has anywhere from 10 to 20 responses, probable responses generated. By default, every system will give you a response that's sitting right in the middle of that probability scale. It's probability. These are the 20 possible answers. And it's going to, by default, every AI system is tuned, configured for an everyday user to give you what sits in the middle. And every model has different scales. So GPT, for instance, has a scale of 0 to 2. Gemini has a scale of 0 to 1. So it's 0.5 or 1.0, things like that. You get the idea. So it's a probability machine and it's giving you a probable answer on your screen that's somewhere in the middle. When you're again developing with AI, based on the use case, developers might say, I want to change my temperature to a lower temperature if I want a more deterministic response, and a higher temperature if I want a more creative response. So if I'm doing a task that is very much based on data and numbers and things like that, right? And again, I'm building agents that will be used by multiple people, millions of people. Accuracy is very important for this data analysis. I'm not looking for something that's somewhere in the middle probability. I'm going to say, okay, I want the temperature to be maybe 0.2 or 0.3. So you're controlling where in the scale of probability you want the answer. And again, for creative tasks, you might say, yeah, give me 1.5. I'd love that. So that's what temperature controls. So for instance, I'm going to just put this blurb in GPT and say, give me a blurb on rainbow. Describe a rainbow for me. 3 versions of it. One for temperature point 2, which is more like deterministic factual based textbook version, point 8, which is more default of what we'll see, and 1.5, which is more creative. So you can read this. It didn't, yeah, this is like more of a textbook version, I would say. And then this gives a little bit more magical version of it. So you get the idea. So these are just some constructs to be aware of because you don't know, but all of this is at play every time you go to your AI tool. I'll just take a quick second to show you what the token look like for OpenAI. I've also included a link which allows you to pick your model, and you can see every model has different tokenization and embeddings schema. Even a GPT 4.5 versus a 5.0 will have a different schema for how it tokenizes and embeds. But I'll just show you an example of what that looks like. So this is just again a tool that OpenAI has made available so that developers can see how many tokens a prompt is converting to. So I'll just take this sample text prompt, go to this and enter. And by default, it's selected 5.0, which is great. All right. So I just put my prompt here. And here it's showing me that this prompt is actually converted to 18 tokens, as you can see on my screen. And then this is how it broke the word summarize into 3 tokens, but following is 1 token. And you just see the schema of how it's broken down my sentence into different tokens by looking at the color scheme. And if I scroll down or here, that's the text tokenization. And here I can say, okay, give me the token IDs, which is the numerical representation, the embeddings. These are the embeddings for it. So if I go back here, the word SUMM is the smallest token that GPT-5 has converted it to. And the token for that is 64614. This is the language that GPT 5.0 understands. So when it's constructing a response, like there is a whole pipeline happening, right? You give it something, it first tokenizes and embeds. After that, it infers everything. Then it generates probable output. Based on the temperature, it'll give you an output in the embeddings format. And then there is a converter that will convert these embeddings into text representation for you. So that's what's happening behind the scenes. It's not magic. It's just programming. So this just illustrates how it all comes together. And then just as a reminder, humans are not perfect. Similarly, machines are not perfect. It can make mistake. And these are some common mistakes. There is a whole body of work that goes into evaluating models and then setting benchmarks for different kinds of skills. So reasoning skill, comprehension skills, writing skills, mathematical skills, and the highest test that each model is tested on and benchmarked on is called humanities last test. So I've written a short article on that. I can publish it if anybody wants to understand these benchmarks. But every time a company releases a new model, a new version of a model, it runs through all of these benchmarks, like how humans have to when they progress from when they're graduate to be out in the world. All of these models are run through these benchmarks to see has the benchmark improved from one version to another.